You ever wonder what really, truly makes a brand new car safe? It's not just about the design. It's about the absolute torture testing it goes through. And sometimes the best way to get the inside story on that whole process comes from a pretty unexpected place, like a single job ad. So let's see what this ad can tell us about the unseen engineers who are working hard to keep us all safe on the road. So let's get right to it. What's the invisible force field that takes a cool-looking digital design and turns it into a real, roadworthy vehicle that you can actually trust with your life? Well, it's not magic, and it's definitely not luck. It's a very specific, incredibly demanding field of engineering. Before any new electric vehicle even gets a sniff of a showroom, it has to survive something we'll call the EV gauntlet. And trust me, it's a brutal, systematic series of trials that's designed with just one purpose in mind: find every single weakness before a real driver does. And what parts are getting pushed to their absolute breaking point? We're talking about the very heart and soul of the vehicle. Its chassis, the suspension, the brakes, steering, and the axles. A failure in any one of these isn't just a small problem. It can be absolutely catastrophic. So, who's the person running this whole gauntlet? Well, meet the testing and validation engineer. But honestly, just calling them an engineer doesn't really do the job justice. It's probably better to think of them as a vehicle detective, a professional skeptic whose entire mission is to question everything and trust nothing. Now this is where it gets really interesting, because it's all about the mindset. A designer's goal, right, is to innovate, to dream up something amazing that should work based on computer models and physics. But the validation engineer, their job is to take that brilliant theory and slam it into harsh reality. They're there to prove what actually works when it's being shaken, stressed, and pushed way past its limits. Okay, so to do this incredibly demanding job, these vehicle detectives need a very, very specific toolkit. And it's almost like a secret language, a set of principles and acronyms that lets them build tests that are precise, repeatable, and completely unforgiving.
And here they are, the most important letters in that alphabet, pulled straight from that job ad we mentioned: GD&T, DFM/DFS, and DVP. Yeah, they might look like a bunch of corporate jargon, but each one is a really powerful concept for building machines that you can literally bet your life on. Let's break them down.
First up, we've got GD&T. The easiest way to think about this is like the official grammar for a machine's blueprints. It sets the super precise rules for every part's shape, its size, making sure that a component from a factory in one country fits perfectly with another from halfway across the globe. It's the reason everything lines up exactly right, with absolutely zero room for error. Next is DFM/DFS. This is just pure real-world common sense. A part might be indestructible in a computer simulation, right? But if you can't build it efficiently on an assembly line, or if it's an absolute nightmare for a mechanic to fix later on, it's a bad design, period. This forces engineers to think about the entire life of the part, from the factory floor all the way to the repair shop.
And finally, there's the DVP, or the Design Verification Plan. This is the big one. It's the master plan, the scientific recipe for the entire gauntlet. It lists out every single test, the exact conditions for that test, and what counts as a pass or a fail. With the DVP, absolutely nothing is left to chance.
All right, with this toolkit in hand, our vehicle detective is ready for the main event, the break it to make it test. This is where theory gets a brutal dose of reality. The goal isn't to be gentle. It's to push that vehicle to its absolute limit, finding every single hidden flaw before a customer ever could. But this isn't just about smashing things up randomly. Oh no, it's a meticulous process. First, they execute that master plan, the DVP, running these relentless durability tests. Then, when something fails, and it's supposed to fail in the lab, they move to the most critical step, root cause analysis. So let's say a suspension bolt snaps after 50,000 simulated potholes. The analysis might find that it wasn't a design flaw, but a tiny, microscopic impurity in the steel from a supplier. That finding gets documented and sent back to the designers, making the final product that much stronger. And this quote just nails the core philosophy. A failure isn't some disaster, it's data. You could even say it's a gift. The job isn't just about finding that a part broke, it's about understanding precisely how it broke and why it broke. Was it the material, the shape, the way it was made? That's the real detective work. So let's bring this all home. How does all this connect back to you in the car parked in your driveway? Why does this one very specific engineering role, hidden away in a job ad, matter so much? Well, it's actually pretty simple. Every time you drive over a nasty pothole that you didn't see coming, or you have to slam on your brakes, or maybe take a corner a little too fast and your car just handles it, that feeling of solidity, that is the direct, tangible result of a validation engineer's hard work. They found that component's breaking point in a controlled lab so that you never, ever have to find it on the highway. And what does it take to do this job? Well, the original job ad actually specified a 6-day work week. And that's not just a schedule. It's a pretty stark reflection of the intense dedication it takes to make sure these incredibly complex machines are safe for all of us. It's a real commitment to finding those failures before they can ever become a real problem. So, the next time you get behind the wheel, trusting that vehicle to get you, your friends, your family where you're going safely, just take a second. Look past the shiny logo and the clever marketing. Who are you going to think of? Well, maybe, just maybe, you'll think of that unseen engineer, that professional skeptic who tried their absolute best to break it, all so they could make it safer for you.